In this video series, I show you how I made a shattering screen battle transition for a private project of mine in Unity. Stay tuned. Hi, I'm Roberto and welcome to my channel. Earlier this year, I made a small JRPG inspired game in just around 2 weeks. It was a birthday present for my girlfriend. It's a tradition that I've started 4 years ago. Every year since then, she gets her own small game starring her alter ego, and every year the genre and story changes depending on what games we have played in the year before. For each game, I gave myself 2 weeks, but with the rising complexity of each project, having only 2 weeks this time to create a story with a main quest, design the world, the main character, the enemies, plural, create animations, make some cutscenes, and more importantly, program the game itself, I had to cut off a lot of content I've originally planned to put in. One of it being an old school style JRPG battle transition like in Xenogears. So after I revisited my game the other day, I was kinda sad that I didn't manage to add this effect. And therefore I thought, why not add it post-release? I mean, fixing your unfinished but already released game is kind of how we do it nowadays, right? Right? So let's start with how I make a shattering screen battle transition for my game using Unity and Blender. Okay, so in order to create this effect, my idea is as follows. First, we have one camera that captures the view of the current active camera and renders the scene into a texture. This texture would be then slapped onto a breakable plane and placed in front of a second camera, which is only active during the transition to the battle scene. And after that, we can switch to our battle scene camera however we like. Okay, sounds doable. Enough planning, let's get to work. First, let's create our destroyable plane using Blender. For that, I create a simple plane and use the loop tool to subdivide the face into smaller faces. After that, I use the knife tool to halve each of the squares into 2 triangles. These triangles will later then be individual broken pieces of the plane. But currently, they are just faces on that plane. So to make them be able to fly away, what we need to do is to create individual objects out of each triangle. To do that, we select all the faces and split them by edge, and then separate them by loose parts. Finally, we set the origin points to geometry so that when we rotate the triangles, they rotate around their own center point instead of the plane's center point. Now all our triangles are individual objects. The only thing we need to do now is to create an empty object and parent all the pieces to it. Nice, now we have one plane that consists out of multiple smaller triangle objects. Okay, so let's just export. Not now, Avira. Okay, so let's just export our shattered plane into an FBX file and switch to Unity. Before messing with my fully functioning game projects, what I want to do is to first create a separate Unity project and test out my idea first. With the project now open, I set up a new scene. Okay, so like we said earlier, first we need a camera that captures the same view as our main camera, but instead of putting the captured scene on the screen, we render it into a texture. So, we create a new camera, a new render texture, and a new material for our soon-to-come plane. We set the resolution of our render texture to something reasonable, ideally with the same aspect ratio as our game. Here I use 16:9, but the game I made was in 4:3, so I will change it later when adding this effect to my project. And finally, we set the render texture as an output texture to our new created camera. Now to have our new camera capture the same view as our main camera, we give it the same transform parameters and set it as a child object of the main camera, so that whenever we move our main camera, the capture camera moves accordingly. The transform parameter are already set correctly here, since I just duplicated the main camera before. The next thing to do now is to slap this texture onto our breakable plane and place it in front of a second camera that captures the plane breaking and is only active for our transition to the battle screen. Okay, so I create the new camera and place it somewhere else so that it does not interfere with the main scene. I import our breakable plane that we created in Blender and set it as a child object of our new camera. We rotate the plane so that it faces the camera, since it's invisible on the backside, and scale it to fill the view. Now we create an unlit shader, give it to the material, set the render texture as the main texture of this material, and now all we have to do now is give each triangle this material. And voila, we have our main camera view rendered onto our plane. And we even added the notch for our MacBook Pro users out there. Just kidding, the notch is here because our plane is blocking our main camera view, and so the blocked area is rendered black. Just moving up my shattered screen camera fixes the problem here. Okay, next I create a black plane with an unlit color material and put it behind the breakable plane, so that when the plane explodes, we don't see our scene behind it, but only the black screen, like in Xenogears. And now we need to add only one last thing before we can start implementing our exploding plane script. We need to open up our shader and add just one small line here, cull off. What this does is, it disables the backface culling of our plane. Remember that the backface of our plane is invisible? We don't want that, because it'll look a bit strange when the individual triangle pieces turn invisible while rotating in the air. So by disabling backface culling, we see that our plane now has our captured scene on both sides. Okay, now we can start the code. First, I've implemented a shatter screen test manager script that waits for keyboard inputs to either shatter the screen or reset it to its original form. The functions are still empty, so let's first create a script for the screen object, called shattered screen. This script needs a reference to all the individual pieces. So I created an array of game objects called pieces and drag all the pieces into the array. I then write a public shatter method, so our manager script can call it, and also write a small test shatter coroutine, where I just disable each piece with a small delay. Back to the manager, I give it all the camera object it needs and also a reference to our shattered screen. I initialize the cameras on awake, meaning the main camera is active and all the others are not. After that, I write a shatter screen coroutine that when the shattering is happening, it first activates the screen capture camera for one frame, which renders the scene into our render texture, and then disables the main camera and also our capture camera, since we already saved the scene in our texture. And finally, oh, come on! And finally, enable the shattered screen camera and call the shatter method from the shattered screen script. Now we only need to start the coroutine in our shatter screen function and see if it works. Yes, it works. It's a bit slow, so we can just shorten the delay between disabling each piece, and now it looks like this. Nice. With that, you could already make a battle transition similar to the old Pokemon games. Here you would only need to set the pieces in the correct order so that they disappear accordingly. Okay. Now to the reset function. In the manager script, I enable the main camera, call the reset function of the shattered screen script, and disable the other two cameras. We need to call the reset function beforehand because our shattered screen is a child object of shattered screen camera. In the reset function of the shattered screen script, I just re-enable all the pieces. In order to avoid any complications, if I press reset while the effect is still going, I created a reset bool variable and added an if statement in our coroutine. If reset is true, we jump out of the for loop. Now we just need to set reset to false when we start the shattering and true when we reset our scene. And I'm just going to put this right over here, just for more structure. And there we have it, a working, simpler shattering screen that we can reset and shatter as much as we like without restarting the game in the editor. Okay, this concludes part 1 of this video series. I hope you liked it so far, and if so, why not give it a thumbs up? I'd really appreciate that. And thank you so much for watching, and I hope to see you all again in part 2. Until then, ciao.